very good evening and a warm welcome to today's hands-on bootcamp where you will get to build a fully working application in just under 30 minutes. I am 𝗖𝗲𝗿𝘁𝗺𝗃𝗂𝗏 and I'm the Director for Community and Partnerships with 𝗵𝗲𝗿𝗂𝗏. 𝗵𝗲𝗿𝗂𝗏 is a SaaS technology company supporting over 1 million developers worldwide build their ideas faster by reusing open source software. Our vision is to reinvent digital realization. Very simply put, we'd like to improve the way applications are built. We do this by investing in a unique combination of both public domain knowledge and artificial intelligence. So coming to today's bootcamp, this is an integral part of our 𝗵𝗲𝗿𝗂𝗏 community initiatives. The 𝗵𝗲𝗿𝗂𝗏 community is a body of like-minded technology enthusiasts and open source contributors who have come together with the vision of contributing to the world of open source and sharing how complex use cases can be developed by reusing open source. Over the last few weeks, we have run several such open source development bootcamps on a variety of topics, such as building your own AR-powered e-commerce site, building your own ChatGPT, building a breast cancer prediction engine, building an object detection engine, basics of Python programming, and many more to come. Through these bootcamps, you will realize that technology does not have to be complex and definitely does not have to be developed in silos. You will see how you can take a solution that is pre-built, in fact pre-built by many people in the world, and then you can build on top of it and share it back such that your solution can now be accessed by many other people in the world who can then further build on top of your ideas, thereby accelerating this virtuous cycle of innovation and also helping you scale your ideas and bring it to life much faster. So with that brief introduction, I will now welcome our mentor for today's session, 𝗵𝗲𝗿𝗏𝗂𝗏, who is a senior developer advocate with 𝗵𝗲𝗿𝗂𝗏.
Hello everyone, welcome to today's session on breaking boundaries with image segmentation, and here we'll talk about two very interesting models. We'll talk about Meta's AI segment anything model, and we'll also talk about Google's 𝗵𝗲𝗿𝗏𝗂𝗏. So stay tuned. Let's first get into the agenda for the day. We'll do a bit of introduction, what image segmentation is, what are the different techniques that are there, and what are the different techniques that are used to segment an image. We will also discuss what has, historically what techniques have been used, and how today we will have two very interesting models, one doing image localization, another model helping us segment different components in the image. So we'll talk about all of these, and then we will get into the solution source. So let's get started. I would first want you to check out our community page where we have our solution source. But even before we start setting up this solution onto your systems, I would want to demonstrate to you what solution are we talking about, what kind of a image segmentation is possible. So the interesting thing is that the solution that we discuss about today, I pick up a demo image. Let's say I pick up this particular image, and then you see that there is a person, there's a dog, building, and a person has back, sky. So the interesting aspect is, let's say I just give down here, we can see the tongue of the dog. We can give building in the image, and maybe I also give bag, app. If you would like, you can also check out anything that you feel I should be able to segment from this image. You can put that particular component object of this image into the comments. I'll rerun this model with that particular portion or that particular object that you would like to segment. So interesting part is this is running on a CPU, right? It's very easy to run all of these kinds of models on a GPU, but to be able to run it on a CPU is what the capability we'll see today. And then the interesting part is we are using text prompts, and based on these text prompts, both segmentation, I mean, that particular part of the image will be segmented, or let's say it will be highlighted with a different color. All these tongue, building, cap, bag, all these will be highlighted with different color. And then we will be also able to put bounding boxes around these into the second output that we'll see here. So this takes a bit of time, and I think interestingly it's one of the most robust, accurate, and in fact it is speed intensive as well. We are able to do it in nearly close to 1.5 minutes. So that's the most interesting part of this model today. So as we talk about it, I would also like to tell you that this entire kit that is available, so this is the code where we have all the both the models loaded. This you can set up onto your systems by getting through the community page. So let me take you to the community page. This is our community page where you must be currently viewing this session. Here you will find an option for a kandi one click kit. So go ahead and click on this. Okay, interestingly, I do have my output also. I will first discuss this very interesting output that we have. So if you can see in the image, we have the cap highlighted with a pink color, this bag highlighted with a reddish maroon color. The tongue has also been, highlighted in a pale pink, and then there is this building which is also being differentiated. So the interesting part is in the original image we are able to do both. So this cap is showcasing as a cap, this tongue is showcasing as a tongue, the bag is showcased here, and then the building has also been correctly marked. If you would like, you can add a component, let's say sky, and then I submit it and recheck it. So I'll let this run. It says it will take some 83 seconds. So there were earlier image segmentation models which are taking around a bit of more time, but if with GPU this can run quickly. And now we will discuss how we can set this kit onto your systems directly. So click on the kandi one click kit. It takes you to a kit page. On the kit page we have the instructions listed down. So you have your deployment information instructions here, and if you are following through alongside with me and if you are on a Windows system, then you can simply follow what I'm doing. If you are on any other operating systems apart from Windows, then you simply download the repository from here and then manually open this model. So we'll go ahead and click on this one click installer. This will download a zip file. You can just say show in folder. So that way you will be able to see exactly where your folder has downloaded. Right click it, say extract all. Only after you have extracted this folder, double click the folder, double click this image segmentation batch file, say more info, run anyway. So this will automatically start setting up the kit for you. You can check the progress here. Currently it is at 5%, and then rest assured it will keep setting things onto our systems. So let's get back to our solution. So now you see that as we put up these details here, it has been able to also mark the sky. If I download this image and showcase you by zooming it, so the cap has been clearly identified, the tongue has been clearly identified, the building is there, the bag is there. If you see, that has been correctly labeled, as well as the sky has been labeled as a outer box. Okay, so that is it. And yes, your segmented model where you see a clear separation of the images with different colors. So different portions of the image are simply highlighted. So this is your solution source. So just let this kit set up for you. Okay, this will reach this 100% onto your systems as well. This has SAM as well as OWLIT. It may take some time. So based on your bandwidth, it will set up onto your systems. let it set up. In the meanwhile, we will discuss the concepts for today's session. Okay, so let's talk about image segmentation. I just showcased you what is being expected from this session. You are actually going to use a technique of computer vision, and we want to extract meaningful information from images. You can have images which you may like to segregate, separate different objects from it, differentiate it from the background. So this process of dividing your image into multiple segments, where you want to draw meaning and you want to have a different, every object represented by a different color or a region within the image, is what we are calling image segmentation. And this technique of image segmentation, we often see there is object detection, where objects are often represented by different bounding boxes, which are like drawing a rectangle around the box. But these rectangles, given a general idea, they give a general idea of the object's location, but they don't show the exact shape of the object. So your bounding boxes, they may also include parts of the background or other objects inside the rectangle, right? So with this segmentation technique, the difficulty in order to separate overlapping objects is completely removed. Your segmentation masks are like drawing a detailed outline around the object, following its exact shape. So this allows for a more precise understanding of the object's shape, size, and all of that. So that is the big advantage of your image segmentation. And the goal is to the change simplify or change the representation of an image into something that is more meaningful and easier to analyze. And you can use it as in autonomous vehicles, medical image diagnosis, object recognition. So how does this work? So we follow a semantic segmentation technique. When we say we follow a semantic segmentation technique, uh, we basically are. If you check out this image clearly, here you would see that every portion of the image, the sky is numbered with, let's say, the number one. So basically, there is assignment of labels to pixels to identify objects. You have images which is a form of pixels, right? So all those pixels are labeled. Let's say the sky is labeled in the blue color. The building is labeled with the yellow color with the number two. And then similarly, you have sidewalk, you have your dog, you have the tongue, you have, whatever you could recognize, the person, the cap, the bag, whatever is the object that could be recognized, they are somehow represented with these semantic labels that you can see on the right side of the image. And that's how the assignment of labels to pixels are done, so that the important elements in an image are clearly identified. What types of image segmentation we have? There are various techniques. We are discussing the prime ones. So there is thresholding. This technique does what? It divides the image into groups of pixels that are above or beyond a certain threshold value. So you mention a threshold value, and then based on that, your image is being divided. Then there is clustering, where your pixels are grouped based on similarity, say in terms of color, texture, and the features. So that kind of clustering is done. Then there is edge based. So this one is an interesting one, where the boundaries in the image are identified using edge detectors, contour detectors, or your watershed techniques. So we would be primarily focusing on the thresholding one for today. And then there is region based as well. So divide the image into meaningful regions using region growing, split and merge, or graph based techniques. So we do have different types of segmentation techniques. Irrespective of all of these, there are challenges. So there is a lot of noise and irregularities. You can often see that there are issues while we are trying to segment a particular image. There is overlapping with the background. There is overlapping between the images. That's what there is object ambiguity. I'm mentioning the tongue, and let's say currently we were able to clearly see that we are talking about the dog's tongue. But supposedly there is a person, and that person is also laughing or enjoying. So there could be image which have different colors, textures, and shape, similar sort of images, making it hard to segment them. And then there is a major component, the time and the complexity that is required for this segmentation. So it could be really time consuming and computationally really expensive. You just saw that we are able to draw it down within, nearly a minute for so many text prompts that I had put into that particular image. So especially for the large and complex images, you are able to do it with segment anything model, which is being introduced by your Meta. And first, we will also talk about OWL-VIT, which is your vision transformer for open world localization, which is also one of the latest models being introduced by Google. So, what is this used for? This VLIT, it's a novel framework that it uses a self attention to mine useful visual cues for open world object localization. At the end of the day, I have to locate a particular object within the image. Also, to bring to your notice, there are poll questions that are present on the community page. You guys can go and interact with the polling questions as well as we discuss the topic here. And these object localization is what makes it much more accurate than the traditional method that are being followed. So this Google's model, it has been pretty much based on the transformer architecture. It is pretty much faster, more efficient than whatever algorithms that were used previously, and it is also able to give us a state of the art performance. So that is what is being required. Where can we use it? It can be used in complex scenarios where you have complete urban scenery, autonomous driving. So I'll showcase that it will be also used in autonomous driverless cars. It can be used in critical infrastructure inspection. In fact, we would talk about this quickly. Your segment anything model. So your SAM or your segment anything Meta's AI model. This is very interesting part, that it is capable enough to actually identify images which it had also been not trained on. So then this zero shot generalization is the mechanism where your unfamiliar objects and images, without even requiring any additional training, the model is able to detect many images based on just simple prompts that you are able to provide it. So there were some 11 million images, from which 1 billion masked images were trained, and this is the most extensive segmentation data set till date that has been introduced, and it is a foundational model that has been provided by Meta, and not a lot of fine tuning is required at current stage. We can see it can able to work in medical imaging as well. So the advantage is it is highly efficient. It is, if you see, uses your spatial information, enabling it to process large data set and make really quick responses. Then this is pretty robust. You can extract relevant features even in noisy and cluttered images. So I'll showcase you a very interesting image of a brain tumor, a brain tumor image. That also it is able to recognize for tumor, right? So that's the interesting part of SAM, and I'll showcase you that. And the accuracy is obviously state of the art. So the precision, recall, your iPhone score, it is a very powerful tool. The SAM will actually help in revolutionizing how we interact and how we do image segmentation. So I think with this we now quickly move to the importance of open source. I want to tell you that it's very important that we see that everything now is being available as an open source tool, right? So when you develop using such libraries, which is available to anyone and everyone, only a couple of things are there which you need to remember: the support, the security, the quality, and the license. All these you can simply find on kandi.openviewer.com by directly checking out that particular library or repository. I will now quickly take you into a simple code snippet exercise that we will do. By now, your kit should have been clearly set up. So we'll just go and check out our solution. So we already discussed this is our solution. Your kit should have been installed at 𝗖𝗵𝗿𝗂𝘂𝗂 image segmentation. You just have to say Y and enter. The kit will automatically open for you. Okay, just say Y and enter, and a Jupyter notebook will open for you. You just have to restart and run the kernel, and that way the same kit will be available to you guys. Okay, but before we go ahead and discuss image segmentation and the solution, I just want to do a simple code snippet exercise with you guys, for which I will open a new notebook, and then I will head over to kandi.openviewer.com. At kandi.openviewer.com, you are able to search for functions, code snippets, libraries, kits based on your area of interest. So for now, I want to find a code that can help me divide image into two equal parts using OpenCV. So I'll put up my search query as divide image into two equal parts using OpenCV, and then I'll hit find. And then what I can simply do, I'll click on the code snippets, and then I'll see that I'll get some suggestions here for interesting code snippets that I can use to actually divide the image into two equal parts. So I see that this looks like a solution that I may be able to tinker with and use in my notebook. I'll copy this, paste it here, and then I will actually require an image that I have to read here. So I'll go to my folder, which is there in 𝗖𝗲𝗿𝗁𝗂𝗂𝗂𝗂𝗂𝗂𝗂𝗂𝗂𝗂𝗂𝗂𝗂𝗂𝗂𝗂𝗂𝗂𝗂𝗂𝗂𝗂𝗂𝗂滬̈ And then in this image segmentation, I have this image. I can pick any images. Let's say I pick up this car image. I'll just paste it in this particular space. So this image is here. I will read this image car, and it is PNG file. All right. So it will first showcase me the original image, then it will wait for me. Then what it'll do, it will print. So this print command has to come into your brackets. So I'll just make the required changes in the syntax. So how are we dividing? We want to get the ending pixel coordinate, the bottom pixel coordinate, and the top pixel coordinate. So we will divide the image horizontally such that there is a top part and a cropped bottom part. Okay, based on this code, if you see. So let me just say Control Enter, and then so this is the image. Okay, this is a pretty big image that it has showcased, and when I crop it, it tries to showcase me the bottom part and the top part. So I'll pick up the other image that was available. Let's say to showcase you the demo, this 𝗖𝗲𝗿𝗂𝗂𝗂𝗂𝗂𝗂𝗂𝗂𝗂𝗂𝗂𝗂𝗂𝗂𝗂𝗂𝗂𝗂𝗂𝗂𝗂𝗂𝗂𝗂𝗂𝗂 This image, car images actually a very big size image, and hence it is getting onto the entire screen as in the original size. So I'll rerun this. Okay, stopping it and running it again. 𝗖𝗲𝗿𝗂𝗂𝗂𝗂𝗂𝗂𝗂𝗂𝗂𝗂, I think we do have a different format for A. Yeah, it's a JPEG file. So let us change the format. And now running it, we will have first the original image. Okay, we have the top part of this image, and then we have the bottom part of the image. So this is a simple code snippet exercise that you can also do as we are discussing through this session. And now quickly I'll move to my kit. Okay, I just had to head over to kandi.openviewer.com, and there I was able to find a simple code snippet for dividing my image into two equal parts. Then comes in your source code. So here we are importing the argument pass so that we are able to enter some commands through the command line. Your import for OS, then for copying. Torch is again used for computer vision task. Then PIL to draw the image as well as put up that bounding box, etc. then there is PIL, then Gradio for interfacing. So the essential ones are from transformers that we have imported this OWLVIT processor as well as the OWLVIT for object detection. So next is from segment anything model, we use the build SAM and the SAM predictor functions. We have imported the OpenCV, NumPy and Matplotlib. And for garbage collection, we have imported the import GC. So we will first check if a GPU is available, then this could run pretty fast. If not, then we'll run it on a CPU. Okay. And then as we run it on a CPU, we're trying to load the pre-trained OWLVIT model for object detection here onto the device, which is in our case CPU. And then we set it to a evaluation mode. So after we set it into an evaluation mode, we also load this model into your processor, the OWLVIT processor, so that this method is used for the model for object detection, and this is used for your OWL for localization of the object. Then you also run your SAM predictor as a checkpoint to load it into the SAM underscore predictor variable. So then we have functions for masking and box creation, etc. You have show mask, show box, plot boxes to image. So here what we are doing, we've defined that we would want to, if there is a random color, then with your numpy.concatenate, you are showcasing with the randomness what color has to be put onto a particular segment or object. Else we are defining a 30 by 255, 144 by 2. So 255 is again the standard way in which we are representing our image. Then with your height and width, you say mask.shape. And that's how you simply want to show the masked image here. So I am show masked image is how you are able to showcase your masked image here. And then with the show box is what you are using to put the outline of the boxes that you are seeing in the image. So both showcase, this is simply just the boxes, and here you have labeled the boxes within the original image. So first for the first image, you showcase the box, four coordinates for the boxes, and then to be able to plot boxes to image, here you are defining the size, the box, and then the label. So the interesting thing is that you then draw this image and into, you bypassing it as an image underscore PIL and save it into draw. Then you showcase the masked part. You want to showcase whatever masking has been done here. Then you draw the boxes and the mask together, right? So for box, label, and zip, you give a random color to the segmented portions of the image. You mention the different coordinates. You draw a rectangle here. Then you put up the label as well. Then the font is also defined with which the label will be showcased, and then you use Matplotlib to no, you here actually draw the rectangular box and the outline of the text box that will be showcased. You then return the image as well as the masking that has happened on the different image objects. So this is the main function which is used for segmentation and detection. Here you load the image first, then you pass the text prompt. What are the components that you want to split, or let's say the components that you would like to check out in the image? You set the box underscore threshold with a standard 0.0 value, and then you run the object detection model here. Your target images, you have to rescale for the box prediction to happen. You convert them into suitable tensors. Here, then those tensors are being passed with the relevant threshold value, and the sigmoidal function is what is primarily used for calculating the scores. Okay, the output scores for the image. Your top K score, your top K IDs, again, these are what are being used for detection of the image. Then you do the text queries that you have passed. Accordingly, you squeeze and get to the uh, top scores, top K labels, all of that for the image. Then further, what you do, you just want to visualize whatever you have detected or let's say predicted. So you pass it into a dictionary, your boxes, your size, and the label. And then further, what you do, you release whatever has been detected by your 𝗷𝗶𝗰𝘁𝗶𝗃 model. Okay, you release all that memory, you empty cache of the GPU if you have used that, and then you run and then come to your segment anything model. So here you get everything in the form of an array. You change it to an OpenCV image, then you set color to this image. With the CVT color is how you are able to color the portions of the image. Then the SAM predictor is used to set the image. The within the for loop is where your tensor boxes are drawn on the image, and also you then put the coordinates, the labels, and the transformed output is then being mapped with the matplotlib library. So we are using the PLT I am sure to showcase the image here, and the same is then being used to save the image. So you do have an option here to save both the images as well by clicking on that button, and then so this download option is also available here, and then comes in your Gradio that is used for the interface to upload the image, then showcase both the outputs as well. Okay, so separately you can open it in a other browser, and now I will show you apart from this image any other image that we will. Let's go for this particular image. Let's see if it can detect tumor, and also give information on whether it can locate this as a brain. So it does take some 84.6 seconds. We'll have to just wait for this to get loaded. I mean, for the model to be able to run. So depending on the kind of image, the complexity of the image, the time is being taken. And then simultaneously, how many processes are running in your RAM also affects the speed of the model that we are running. If I explicitly just run it single-handedly without any other you know other thing being occupying the RAM, then the speed of the model will be pretty much more. So we'll just wait for this to be able to showcase that how it can be utilized in medical imaging as well, detecting or let's say stating whether there's a tumor or not. So we'll just wait for this model to run and showcase us the results. So we have the final 10 seconds left. So possibly this has been an interesting model where it has been usually able to give us the you know expected results. So it has taken beyond what we were expecting, right? It has taken more than the time duration that were it is showcased initially, right? So if you see for this particular image, I did mention tumor, but it was not able to detect. However, for another image, a grayscale one, I mentioned tumor and brain, and then submit it. It will be able to state this image as the expected outcome will be showcased for this particular image. Also, in the meanwhile, you can go ahead and put your questions in the comments. We'll take them one by one. We do have to wait a bit so that we are able to get close to the output. But yes, I do have other images as well where you are able to, like for this image, the model is clearly able to bring out the tires, the windows, the background here, the sidewalk, all of it separately. Similarly, for this cyclist image that I would like to run, I'll showcase you how the cyclist image also it was able to give us the relevant expected output. But this should be an interesting one to see whether it is able to detect the tumor within this grayscale image or not. You may actually run any of your images and put up your text. So yeah, it's able to say the brain and the tumor, right? If you download this image, you'd be able to see it was a small image. It's able to mark the tumor as well as the brain also within this. So similarly, and then showcasing it with a different segment, color segment. So then with this, we actually now want you to, I'll run another image quickly, and then we'll open it for questions, and then we'll come back and I'll check out. Let's say I want to detect the helmet. I want to detect the bicycle, and I'll submit this and wait for it to run and showcase me the results. So I think today we tried to discuss a model which will help segment a particular image into various objects, object segments. But as we discussed this model, we also learned about not only your segment anything model of the amazing Meta AI's development, but we also discussed Google's object localization model. So that OWLVIT that we discussed is also very interesting model that you can use as an application for your solutions where you would like to do object localization. So before we check out the solution, going back again, since it takes a couple of minutes, I'll now quickly take questions from the community. So there is one question that is being asked from one of our members where they have asked, what are the other techniques that are most uh, interesting and are helpful in image segmentation. So we did discuss about thresholding. We do set a threshold value. The clustering, there are different deep learning mechanisms as well. There is watershed and graph cut has also techniques that you can use for segmentation of images. The advantage that is being asked, and then there is another question that is being asked by a community member: what is the main advantage of using OWLVIT model? So your VIT in itself, which is your transformer architect, which works on the transformer architecture, it's a very powerful model for image recognition, which runs really fast. So we need some fast recognition to happen in our images. We can't keep waiting, like 1.5 minutes is good enough, but something beyond that is too much to wait. So with Google's VIT, we are able to localize the image well. And if you see in this particular example, the bicycle has been traced, right? As well as the helmet, one of the helmets is also being segmented. And then it is able to segment and showcase this image with the bounding box as well as the label. So I hope this solution was interesting for you, and you are able to gather interesting insights from the most interesting model that is the most interesting and the foundational model introduced by Meta. So thank you so much.
Thank you, Pooja, for that lovely session. For all our viewers and bootcamp participants, we hope you enjoyed the session and found the use case that was presented valuable. Please note that all of you who participated will be eligible to receive certificates for this bootcamp. In order to receive your certificate, please complete the assessment by answering 2 very simple questions. You can do that by scrolling down from on the same page where you're viewing the bootcamp today. You will find a Take Assessment button. Click that button and complete the assessment. You should then receive your certificates in less than a week from today. We will be conducting such bootcamps frequently and regularly. So if you'd like to stay updated with our program calendar, do join our community on community.openweaver.com. This community is where we will connect with you. It helps us receive feedback from you. It helps us understand topics for future bootcamps. But also you can use this community space to collaborate with each other, to ask us any questions and receive clarification if you'd like, or just share your projects and anything else that you would like to in the world of open source. So do join our community and also follow us on our social media channels to stay updated on information and trends in the world of open source. With that, I would like to thank you all for your participation today, and I look forward to seeing you in yet another bootcamp very soon. Thank you and good evening.